In this how-to video I'm going to explain disproportionation, and to help me I've put some notes on the screen. So firstly, what is disproportionation? Well, disproportionation is a reaction when a single element is both oxidized and reduced at the same time. And here's the example with chlorine added to water. So pictorially what I've done is I've represented the chlorine atoms in this chlorine molecule one underneath the other. So this is one of the chlorine atoms and this is the other chlorine atom. And we need to remember a little bit about oxidation and reduction or redox reactions now. We need to remember firstly that uncombined elements, molecules of elements, have an oxidation state of 0. So these two atoms of chlorine in this chlorine molecule have an oxidation state of 0 and 0 to start with. Now if we come over here, we've got two compounds formed. We've got chloric acid and we've got hydrochloric acid. And what we now need to do is to look at the oxidation state of the chlorine here and here respectively. And again we need to do some remembering about simple redox reactions and oxidation numbers. And what we need to remember is oxygen combined always has an oxidation state of -2. And hydrogen combined has an oxidation state of +1. Now you'll notice on both of these molecules there isn't any charge, any residual charge. In other words, I haven't got a minus sign here or a plus sign, and I've got neither a minus sign or a plus sign here. So these are neutral molecules. They're not ions, they're molecules which have no charge. So what that means is that the minus oxidation numbers must equal the plus oxidation numbers. So they effectively cancel each other out to end up with no residual charge on either of these molecules. So going backwards then, if we look at oxygen -2, hydrogen +1, it becomes obvious that this chlorine must also be +1. Because if +1 +1 and -2 is 0, so no residual charge. So one chlorine atom here has effectively lost an electron to become 1+, and that's oxidation, because oxidation is loss of electrons. And if we come over here, hydrogen is +1, so this chlorine must be -1, because again we've got no residual charge on this molecule. So the second chlorine atom in this molecule has gone from 0 to -1. In other words, it's gained an electron, and that's reduction. So oxidation and reduction happening at the same time to the same element, disproportionation. And this is a second example. Again with chlorine, this time with sodium hydroxide. We've got two molecules with chlorine formed, here and here, and the same rules apply. If we look at this molecule, combined oxygen -2, sodium is in group 1, so it's got an oxidation state combined of +1, and because there is no residual charge, this chlorine must be +1. So it's lost an electron, so this chlorine is oxidized because oxidation is loss of electron. And if we look at this chlorine here in this molecule, sodium group 1 +1, so this chlorine must be -1 because there is no residual charge. So the other chlorine has gone from 0 to -1. In other words, it's gained an electron, so that's reduction. And that's what disproportionation is. It's both oxidation and reduction happening to one element at the same time. And these two examples of chlorine with water and with sodium hydroxide are the two which normally appear in exam questions and on exam papers. Hope that helps. Thanks.